Very good evening, guys, and today we are going to discuss some short questions from the chapter 2, and short questions are very important and it may contain 7 or 10 marks in final exam. So the first question is: a hollow metal sphere of radius 5 cm is charged such that the potential on its surface is 10 volt. What is the potential at the center of the sphere? Okay, so hollow sphere তোমার কি হয় গোটেখিনি চার্জ যেটো ডিস্ট্রিবিউট হৈ আছে তো তার সারফেসত যিমান পটেনশিয়াল হ'ব তার সেন্টারটো সেম পটেনশিয়াল হ'ব কারণ গোটেখিনি সেন্টার কনসেন্ট্রেট হৈ থকা যেন লাগে so that's why the total potential will be same and that is the 10 volt. Now in the second question, draw an equipotential surface for a uniform electric field. So equipotential surface মানে কি প্রত্যেকটো পয়েন্টত তার পটেনশিয়াল টু সেম. So for equipotential surface, suppose electric field is along x-axis, then equipotential surface are always normal to the x-axis. The x-axis of the electric field থাকে তার normal তার যেটো perpendicular সেফালে তোমার কি থাকিব equipotential surface থাকিব. So this is the diagram you can see here. So if that is perpendicular to x-axis, so that means that is parallel to the yz axis. Am I right? Okay. So now, what is the amount of work done in moving a 200 nanocoulomb charge between 2 points 5 cm apart on an equipotential surface? Okay. So equipotential surface এটা তোমার এটা চার্জ আছে 200 nanocoulomb তাক যদি তুমি 5 cm দূৰলৈ লৈ যাব বিচাৰা তেতিয়া কিমান work done তুমি কৰিব লাগিব. Now what is the expression of work done? Work done means charge into the potential difference. So there is a potential difference. Suppose you are going to move the particle from A to B. Is the change in the potential energy or potential. This is called potential difference. Now if there is a equipotential surface, so that means VA equal to VV. So VA and VV are same, so obviously the work done will be 0. And for an equipotential surface, you want to move something, then you don't have to do any work. Okay. Now the fourth question is: name the physical quantity which has its unit joule per coulomb. Okay, is it a scalar or vector? Joule per coulomb কোনটো মানে physical quantity unit হয় সেটো হৈছে তোমাৰ কি potential, electric potential, and that is a scalar quantity. Now you have to find out the dimension formula potential difference. Now already we discussed that there is a basic difference between potential and potential energy. Now you have to find out the difference of the potential, dimension of the potential difference. So that means the dimension of the potential. ঠিক আছে, তো potential মানে কি যে work by charge এটা work by charge. So dimension of work কিমান হয় ml squared t⁻² and dimension of charge, that is q equal to it asile. So dimension of I is a and time is capital T. So this is the dimension of potential difference. Final dimension is this. Okay, so these are very important questions. Now you have to write an expression for potential at a point P here due to 2 point charges Q1 and Q2 at R1 vector and R2 vector. So what does it mean is that Q1 and Q2, the position vector of Q1 and Q2 is R1 and R2 from the origin, and there is a point P, and there the position vector of that point P is R from the origin O. Now what is the now if you want to calculate the potential due to charge Q1, then you have to know the distance between Q1 and P. If R is the distance from the origin and R1 vector is the position vector of Q1, that is from the origin, then what is the distance between P and Q? That is obviously modulus of R vector minus R1 vector. Okay, because distance is always a positive quantity. So this is the expression of potential due to Q1, and similarly you can write the potential due to Q2 is this. Okay, the same thing. Now what is the SI unit of line integral of electric field? Okay, so electric field or যেটো line integral কৰিছিল হেতু তোমালোকে পাইছিলা সাকে যে যেটো electric potential আৰু electric field এর relation আছে. So line integral of electric field is always a volt or voltage. So obviously its SI unit is joule per coulomb because volt equal to work by charge. Now in a certain 0.1 meter cube space, electric potential is found to be 5 volt throughout. What is the electric field in this region? Okay, so the question is that electric potential is found to be 5 volt throughout. So 5 volt গোটেখিনি সার্ফেসৰ তাকে অন কৰিছে same electric potential 5 volt আছে. So obviously electric field is constant. যদি same value থাকে, then obviously the electric field will have the same value at the all points. So if electric potential is same, if electric potential is constant, then what is the relation between electric field and potential? This is the relation between electric field and potential, and from this expression we can say that E will be 0, because if you differentiate any constant quantity, that will give you a 0. Now let's move to the next question. Will there be any effect on potential at a point if the medium around this point is changed? Yeah, obviously, because in the potential expression we know that there is a, if potential in a vacuum, there is a term that is called epsilon naught, that is called permittivity. Am I right? Permittivity in free space. Now if the potential is not in the air or vacuum, if you place in some, if charge is placed in some other medium, then obviously a different quantity will come, that is called dielectric constant, that is K. So this potential will decreases with the increase of K, because that is inversely proportional to K. Okay, so etu kotha hoise ki epsilon naught jitu asile ami bahut bar koisu, jitu epsilon naught etu tomar only jitu vacuum by air tathe applicable hoy. But if you place the charge in a different medium, then you have to add a relative permittivity, and that is called dielectric constant. Okay, in air or vacuum, the value of the relative permittivity is always 1. Then again, one question is this, it's the same question. Okay, now the middle point of a conductor is earth, and its ends are maintained at a potential difference of 220 volt. What is the potential at the 2 ends and the middle point? Okay, so koise ki the middle point dot tomar ki kora hoise earthing kori thoa hoise. The potential je kono tomar eta conductor ami jeta saisibo dukhon plate rahi hoisilo, potential at the middle point is 0 hobo kior karone the values of potential at the 2 ends of the conductor, eta conductor must be এটাৰ ফালে কিমান হ'ব লাগিব 110 ভোল্ট আৰু এটা এন্ডত কিমান হ'ব -110 ভোল্ট হ'ব লাগিব, তেতিয়া ইহতৰ পটেনশিয়াল যে ডিফাৰেন্স এটো কিমান হ'ব, this is like VB minus VA. Okay, so suppose VB is 11 volt and VA is -11 volt. So what is the potential difference? This minus this, that is 220 volt. তেতিয়া তোমাৰ potential difference এই হ'ব, যেতিয়া দুইটা চাৰ্জ এফালে opposite charge of same magnitude থাকিব, then obviously that মাজত the middle point of potential কিমান হ'ব 0 হ'ব. What is the electrostatic potential due to electric dipole at the equivalent point? Direct question, and we know that the electric potential due to electric dipole at an equivalent point is always 0. So define the electrostatic potential energy. Now how many electron volt make 1 joule? And we know that 1 electron volt equal to 1.6 × 10⁻19 joules, and obviously from this formula you can calculate 1 joule equal to this number of electrons, 0.625 × 10⁻19. Now what is the potential energy of two equal negative point charges 2 microcoulomb is held 1 meter apart in air? Okay, that is air, so you have to use only the epsilon naught, you don't have to include the dielectric constant. Now you have to find out the potential energy of two equal negative point charges. Okay, so this is the expression of potential energy. Already we discussed that potential and potential energy are two different things, Q1 and Q2 divided by 4 pi epsilon r. So both are negative charge, so just put the value here. This is the 1/4 pi epsilon 9 to 10 to 9. After solving this formula, you will get this is the potential energy. No work is done in moving a test charge over an equipotential surface. Now they are asking that why we don't have to perform any work in an equipotential surface, because work done equal to charge into potential difference. Now if there is a equipotential surface, the potential difference is always 0, and therefore you don't have to perform any work done. Okay, now next move to the next slide. 5 joule of work is done in moving a positive charge of 0.5 coulomb between 2 points. What is the potential difference between these 2 points? Okay, now potential difference is always work done by charge. So what is the work done you have performed? This is a 5 joule and charge is 0.5, so this is the potential difference. This is direct formula, 10 volt. Now a charge of 2 coulomb moves between two plates maintained at a potential difference of 1 volt. What is the energy required by the energy charge? Now the same thing, energy required or work done is same, so energy required Q into V. Q is the potential difference, so just put the values and you will get the energy 2 joule. A charge of 1 coulomb is placed at the center of a spherical shell of radius 10 cm. What will be the work done in moving a charge of +1 microcoulomb on its surface to a distance of 5 cm? So at কি কৈছে যে এটা চাৰ্জ তোমাৰ 1 coulomb spherical cell center আছে আৰু এই spherical cell টোৰ যে radius is 10 cm, What will be the work done in moving a charge of 1 microcoulomb on its surface to a distance of 5 cm? Okay, so surface jodi loi jao tak moi 5 cm pora kiman work done lagbo. As the surface of spherical shell will be a equivalent surface, ta mane ki hoy spherical shell jodi expression paba tumi, the spherical shell jodi surface hoy that is an equipotential surface. So if there is equipotential surface, then you don't have to perform any work done. So work done moving a charge plus 1 microcoulomb for any distance on S will be 0. Okay? So that's all about the short questions from the chapter 2. Thank you very much.